Welcome back, folks. This is Joaquin and Kevin, host of the Thinking Ahead podcast series here at Neuroscape from the Digital Health Core of Psychiatry at UCSF. My guest today, let's high five again. Kevin Jones.
Felt that power behind
That's
that
big.
one. Yeah.
Kevin Jones, postdoc extraordinaire, cognitive neuroscientist, homie.
That's right. Thank
Here we
you
go.
very much.
So today we're going to be talking about specifically a lot of things related to trying to improve brain function, in this case especially in older adults. So let's just start with, what is cognitive decline and what are hallmarks of it?
So we all have those sort of senior moments, even if we're not seniors. This happens to me all the time.
Me too.
I'm in my 30s and I feel
I'm
like...
in my 40s.
Yeah, I feel like my cognition has noticeably declined. However, that's not all doom and gloom. So our brains finish sort of maturing in our early 20s, and it's sort of all downhill from there. But that doesn't necessarily mean that we fall off the face of the earth cognitively.
How
right away.
slippery is that slope?
So it's a slow and gradual decline. Every
Okay.
decade, you become sort of worse at multitasking, at ignoring irrelevant distractors.
Okay.
Your short-term and working memories, we'd call it, sort of declines, your capacity. But your semantic knowledge generally stays crystallized, sort of your knowledge for facts.
So I'm wiser. It's true.
You
I
are
get
wiser.
older.
Yeah.
Okay.
You use
All
your
right.
brain maybe more efficiently because you have fewer resources now
I like
that you're
that.
older.
So with all that to be said, what are people doing to try to make up for this?
So-
I'm sure that things have been around for years and years and years to try to make things better, but what are we doing these days to try to make up for these things that are kind of going down this slippery slope?
Yeah, that's a great question. And this is a huge industry that spans lots of different fields. And so there are plenty of people who just simply exercise, socialize, eat properly. The whole Mediterranean diet has been a fad for a
Huge
while.
fan over here.
Yeah, me too. But the idea that you can actually train your brain to either improve your overall memory or rescue lost cognitive abilities, this is quite a big research, rehabilitation, and commercial industry.
Okay.
Where over the last couple of years, it's over $1 billion industry of just brain training games that may or may not actually work as effectively as they are advertised.
At least my understanding is there's more may nots than mays.
There are, and there's generally what we describe as you get pretty good at the game that you've been playing, but that may not actually transfer the benefit to your everyday life.
All right,
And
so besides these games that people could play, I've heard of other things people do in terms of zapping their brain and actually getting something out of it.
that's right. So there is a way to sort of gently fry your cortex.
Gently.
Gently fry your cortex with a
all right.
small amount of electricity in a beneficial way when you know where you want to stimulate your brain and specifically how.
I wanted to know more about where and when people were doing this and how far back it goes using some kind of stimulation stuff.
That's right. So while the research and commercial and rehabilitation use has really taken off over the last 20 years, since about the year 2000, if you search back through the annals of history, you'll find that this is actually ancient Greeks.
Ancient Greeks.
Ancient Greeks actually used electric fish, eels, for medicinal purposes to actually sort of try to treat epilepsy and other sort of conditions.
They'd put fish on heads.
They would put fish on heads, and
Amazing.
this is back from someone named Pliny the Elder. Was one of the few people who did that.
How do I know this name?
All right, so that might sound familiar, especially if you're into the craft beer scene, and if you went a little bit north of the Golden Gate Bridge, you go right up to the Russian River Brewing Company,
And?
they have a beer
Pretty
commonly known
placement.
as Pliny the Elder that
Amazing.
few people know is an actual person.
How about that?
Yeah.
That's medicinal too.
That is medicinal as well, and it maybe won't treat the same things that fish would treat, but maybe more effective as well.
That's fantastic. So there's a history behind the use of
That's
neurostimulation actually get something beneficial out of it, not only from back in the day with Pliny, but even contemporary.
Right.
So you're telling me you have some research that's
do.
related to cognitive stimulation specifically, not Pliny, and not eels.
That's right. And so a lot of people hear electricity through the cortex, and they think, "Oh, I don't want to be in the Green Mile. I don't want to have some electroconvulsive
Mile.
therapy."
Yeah.
This is about 900 times weaker than ECT or electroconvulsive therapy.
Okay.
And so what we do is we have some cognitive training paradigms that we use in the lab or people use commercially that have success. If you actually pair this sort of cognitive training with neurostimulation, it may be an even additive benefit. They may be greater than the sum of their parts.
So it's like, in this case, 1 + 1 = 7.
Exactly.
All right.
That's right. 2 + 2 = 5 here. And so what you do is, if you know, say, your frontal cortex right here behind the beer.
Yeah, let's get the beer out of the way. A little bit out of the way.
If you know that when you are multitasking, you're doing some sort of difficult executive function task, using the frontal cortices of your brain. If I now want to then give that part of your brain a little bit of a boost with some electricity, either direct current stimulation, which just depolarizes the neurons, makes them more likely to fire.
Yeah.
I could then directly target that with the electrodes there to change this resting state.
So why doesn't it go and you put this electricity in your head? Why doesn't it make you worse? Why doesn't it make you better?
Well, people actually have made themselves worse when you just sort of do it freestyle by yourself. But when we know the right region to do it and the right timing to do it, you can actually strengthen the functions that are naturally occurring in your brain. And so you can do that with direct current stimulation, but lately we've been using an alternating current, or when you think of AC current, when you hear electricity.
AC/DC.
Well, that's right, AC/DC.
All right.
And so we're doing the AC part paired with cognitive training in older adults. And we have found that there's a range of oscillations in the brain. We call them the theta oscillations.
Okay.
It's a set frequency of how many times a second the EEG waves go up and down. If we then provide that frequency with our neurostimulation, it's basically strengthening something that is already happening in your brain.
So, all right, I think I see where this is going. If you get one of these devices, you put it on someone's head at the right oscillation, specifically that needs a little extra oomph to do something better.
Yeah.
You get more something out of it.
Generally. However, this research has had some issues of reliability, where maybe not everybody has been benefited from the same paradigm, the same technique, the same parameters, for example.
That's okay. I don't think anybody would expect this to be a magic pill that fixes everybody the same way, right? But at the same time, in this case, you've seen it work for at least one population. In this case, I'm guessing seniors that you've tried with your research.
That's right. And so we've actually been able to speed up the rate at which seniors learn sort of their ability to multitask in like a novel video game scenario. So they've actually used non-boring laboratory tasks. And while they play a multitasking driving video game, we provide them a current we believe is what their brain is already doing, and they improve faster as compared to people who received no current, or those who received a frequency we thought was not advantageous, like out of the range of what your brain would normally do.
I mean, that's fascinating. The idea that you could learn to do something faster, and it actually has benefits by putting something that's a 1/30th of a 9-volt battery up to your head.
Through your head.
It's pretty fascinating. So it seems like it's safe.
Yes.
It seems like it can be done. Why can't we get one of these at Best Buy?
Well, as of right now, people aren't actually using it to be sold sort of as a therapy, so you need to be sort of FDA approved.
Okay.
But as you said, it is safe. There are no known long-term adverse side effects when done properly. It's relatively cost-effective compared to any other technique you'd use in a laboratory. The parts are relatively cheap, and if this is reliably done in a beneficial way, you could see it scale outside of laboratory settings as more of a population-wide public health benefit.
So
once we understand how to do it.
I mean, it makes sense in many ways. You could see if it's helping if maybe a young adult maybe move the needle a little bit, and an older adult that is concerned about their cognition move it that much more, it would seem that to extrapolate from there that we could probably work with certain maybe clinical populations that need to move the needle a little bit more than that.
That's right.
Does that make sense?
Yeah, and so this is actually used quite a bit in rehabilitation for like memory decline. Even it's especially more effective in movement disorders as opposed to cognitive abilities like memory and attention, which are just a little bit more, a lot of different brain regions working together, so it's more difficult to reliably induce a benefit. Or stroke rehabilitation is another big one. And so this technique has been used quite a bit across almost every sort of research domain, and now we are focusing on how to reliably and benefit people, to sort of custom and tailor make it to each individual so that it actually, we can predict when it would work.
Let's talk about the premise of some of the stuff you've been doing, which is this 1 + 1 = 3, or 2 + 2 = 5,
That's right.
And the first one in this we've talked about is neurostimulation. But the other thing is, what do you pair with that to get the more out of it? And you kind of alluded to this idea of brain training, as some people call it, or cognitive interventions. And some of your work, humbly, builds off some of the stuff I did back in the day. This
It's a
idea
nice humble
of
brag there.
you know, I try, I know a little something. And this idea of some games that you could actually utilize these video games in a very targeted fashion to try to improve cognitive function, especially in the elderly. So there was this paper that came out of the Neuroscape back in the day, 2013, gosh, almost 7 years ago, that showed that older adults that play this Neuroracer video game actually show improvements in their cognitive abilities, and these improvements are behavioral and neural and last for 6 months. So
That's right.
that was pretty cool.
And the lasting for 6 months is a pretty long time point for any research.
Yeah.
And the fact that any benefit would last long term is quite exciting. And that's why I believe that paper was so important to the field in general.
Oh, you're so kind, Kevin.
Well, I am.
What a guy.
I am, and I use that task to this day, so it benefits me to pump it up.
All that to say, though, it was also explains and highlights the idea that there is this ongoing plasticity in folks that need it, these seniors that did that study. And you're basically looking to exacerbate those effects by the stimulation, right?
Yeah, and so in that study, they trained over about a month or more, right?
Yeah,
a long period of time. So while this paradigm works, and a lot of the reason this was such an attractive finding is that it was not a boring laboratory task like a lot of researchers use, like just looking at different colored squares and what have you.
I think some of those participants might think it was not that great either. But
well,
but I digress.
They certainly could have been more boring.
They could have been more boring.
That's right.
For sure.
And so if it's more applicable or more engaging, maybe this is actually going to be something that people would enjoy doing, and maybe will be closer to things they do in their everyday life. But rather than expecting everyone to come play a driving video game for 5 weeks or more, what if we could shortcut that training gains and get you to the same overall place, but in a faster speed by sort of leveraging the results of that study. And when we found out that not only were older adults improving on multitasking, but their brains started communicating more like younger adults. Isn't that right?
That's right. Yeah, we saw some neurological signals of brains that previously looked old starting to look young, which is pretty remarkable in and of itself, and at least give you a target neurally, something to focus on in the future for other types of intervention work.
Yeah. And while Neuroracer is just one game, other researchers used other games that people play on the everyday life. So I know some researchers that have used like the Portal video game for brain training, and like Call of Duty, for example, which obviously you may not expect older adults to be playing that very well. But compared to games like The Sims or more common brain training commercial products that have had some negative press for not working so well, these actually have shown to be actually a very effective way to improve multitasking and attentional skills.
So is it really that simple? I could go, again, back to Best Buy, not trying to do product placement, but I could literally get Call of Duty and one of these devices. If I made one at my home, don't do it, and played Call of Duty, my brain would be functioning better than either of them alone, or just gets that much better. That's all it is.
You may be optimizing the way your brain communicates, especially in something that operates in such a fast millisecond scale as reaction times. And if you're actually practicing things that are relevant to what you do in your everyday life, that's not necessarily playing video games, but keeping a running list of, say, groceries or phone numbers, these are things that tax the same underlying mechanisms in the brain, such as working memory, which is very small. It's constantly fading. We all forget why we walked in the kitchen, and then this is just another example of why.
Tell me, I don't know if I'm going to do simulation to fix that, but I am curious to think about what other industries or entities are trying to use this besides, like you said, we're talking about research purposes here, but there's got to be a bigger beneficial effect of using that. And so who is using these kinds of approaches in the first place?
It is much more widespread than you'd realize. And so while we were just talking about games in general, these sort of at-home do-it-yourself devices, which again I don't necessarily recommend for broad use.
Don't do it.
They are very popular among competitive video gamers, for example, who do rely on their reaction time and their ability to learn new skills and target detect very quickly. But more broadly, the military, and actually DARPA, their sort of advanced research wing, has poured a lot of money into neurostimulation research for a wide breadth of professions, from pilots drone pilots and fighter pilots
Really?
to sniper training to even language translators. And they use the same type of technology we were talking about, sort of top down into the cortex, but they also do it from the vagus nerve up into the cortex. And so the same way a drug affects your entire body when you take
Yeah.
it, they like vagus nerve stimulation also affects your whole cortex, or you could specifically target small regions from the top down. And more broadly than just the military, for example, athletes have started to get into this, and so there are some companies that
Oh yeah, Halo.
Halo, right down
Halo.
the street from us here. They've worked with I believe the U.S. ski team. They've worked with players on the San Francisco Giants, I believe.
Yeah, the Golden State Warriors. I
Yeah,
think.
even
Yeah.
special operators in the military as well, like special forces. They've used this idea, and when you, especially with Halo's product, where you're targeting motor regions, the effect is much more clear cut. And so, cognitively, as I was saying, cognitive regions are much more complicated, so it's harder to reliably induce a benefit. But when you're doing motor rehabilitation or learning new motor skills, you can learn these skills faster if you pair it with stimulation to the right region of your brain.
So, this is cool, and we have this technology that seems to have a lot of promise, but it's not readily available, and we need to find a way to make it available if it's safe, if it actually shows efficacy in certain situations for the right person and the right population. So, I think that takes us to the point of where, how do we know what to give to what person, and how to personalize this in the first place?
That's right. So tailor making these interventions is really the next field we are really diving into here at Neuroscape especially. And so, as I said, there's some consistency problems, and we've been identifying these mechanisms, such as differences in people's genotype, their brain anatomy, the size of their brain, and how much stimulation is actually reaching these brain regions we know are important. And so once we identify what an optimal dose is for each person, we can then prescribe that dose when we know what is the most effective peak. And so we're identifying if there is an effective maximum. Does it plateau? Does it eventually, like an inverted U shape, start to come back down? And then for TACS, the AC part of the ACDC, we want to know, does matching the frequency to what your brain is intrinsically naturally doing, is that then even more beneficial than a sort of one-size-fits-all approach, which is how most laboratories do it today?
So in this case, it seems like there's a lot of thought and that you have to think about towards personalizing, make sure it fits the right person. A lot of the things you just talked about sounds kind of like what drug companies probably have had to do and continue to do.
That's
in terms
right.
of thinking of, well, I can't just give the same dose to each person. I need to personalize this, make sure the dosage is right, make sure I tell them how long it's good for, what it's going to be good for, and a doctor typically will tell you this is what's safe and this is what's not safe.
Right.
Have we reached that state with TACS, or are we getting close to it?
We're starting to get close to that. And so we are not necessarily having to worry about an effective and a lethal dose, but more like drugs do, but rather just what is most effective. And so while these effects can be subtle, once we sort of optimize the parameters, we could then scale it outside of the laboratory rather than requiring people to come into clinical settings and come into rehabilitation settings and come into research settings, and which is not necessarily feasible for a lot of people, especially in remote regions. And so not just research devices we buy, but there are some commercial devices that are coming up that, if readily available, the technology underlying them is not necessarily prohibitively expensive.
I guess then that kind of brings up the maybe a final question per se, which is, well, we talked about 1 + 1 = 5, right?
Yeah.
Is there any reason why we wouldn't do 1 + 1 + 1, in this case, the extra one being the pharmaceutical,
Yeah.
right? And trying to see if we can leverage a video game plus TACS plus pharmaceutical to get even more. Is that something that is on the near horizon that other companies are potentially doing?
Yeah, and so there's certainly, you could sort of relate this idea of neurostimulation as a pharmaceutical in itself, or perhaps it's just an additive effect of pharmaceuticals. And the same could be said for video games, for example. Basically, the NeuroRacer game that we had, if it is reliably beneficial to people, then perhaps a version of NeuroRacer maybe could be prescribed in the same way as a video game, if you perhaps know of anything similar to that.
There was recent news that came out with this company called Achille that just had their phase 2 trial be successful, and it looks like they may be a prescribable entity for kids with ADHD, which is pretty exciting.
Yeah.
Let's
A
see what happens.
prescribable video game,
Yeah.
prescribable neurostimulation parameters. These are things that even 5 years ago are widely unheard of in the field. And so I think this leveraging all of these together could really sort of induce lasting cognitive benefit, potentially for not just cognitively declining individuals, to either rescue cognition or prevent decline, but it could potentially help anybody learn new skills or treat other clinical diagnoses like ADHD, like you had mentioned.
That's really exciting to think. Yeah, I mean, I guess its main thing is we know how ubiquitous pharmaceuticals are in our society. The idea that a stimulation may get over these concerns that people might have of, oh my God, I'm going to zap my brain.
Yeah.
But it may surmount those if they can be beneficial and safe and can be treated in such a way. So it seems really exciting type of technology that may lead over all these kind of hurdles in the first place.
Yeah. And it may be just simply much more cost effective if it even gets on the same playing field as some drugs, which you may need to have a prescription for the rest of your life. And that, in this country especially, is not necessarily the most affordable approach to maintaining brain health.
All right. Looks like we have a question from a viewer.
Oh,
Yeah.
great.
We have a question from T Zanto 420. His question is, hey Kevin, I play Call of Duty every day. Why don't I have a 4.0?
Well, thanks for the question, T. Zanto. I would say, first off, probably because you haven't been doing your homework if you're playing Call of Duty all the time. However, I don't know how closely related your academic success is to your Call of Duty skills.
Pretty much not going to be overlapping. So that's going to be what we call far, far, far transfer, some would say.
Yeah.
And in this case, it just doesn't work out that way. They don't overlap enough, buddy.
Right, especially if your perhaps work-life balance is out of whack as well. So this isn't sort of a magic pill effect where it will cure everything in your life. And so you definitely really need to apply it to what you're doing when you talk about neurostimulation.
Yeah.
And video games.
And video games.
Yeah.
Perfect. All right. Well, that's a wrap for now, folks. It's been a lot of fun. Thank you, Kevin.
Yeah, it's great to be here.
I'd like to encourage you to take home this Pliny the Elder.
Really?
And utilize it.
Thank
to
you.
its fullest potential.
I really appreciate that.
And I think it's been fantastic learning about neurostimulation, learning about Pliny, and thinking about where these things can and will be going in the near future. So this will be it for the Thinking Ahead podcast. I'm Joaquin and Kevin, and we'll see you again soon. Thanks so much.
Cheers.
Cheers.